The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick information if you all can see my screen and hear me loud and clear as well? You can all use the questions tab to give me a quick information. Great. Thank you for confirmation, everyone. So before we start, let me quickly introduce our Edurka Masterclass community with you all. So this community of masterclasses was started back in 2019, and since then, we have been closing into more than 2,000 members so far. And in these masterclasses, we conduct multiple webinars and live events on different topics, including blockchain, IoT, artificial intelligence, machine learning, and big data engineering technologies. And the best part about these webinars are they are absolutely free of cost, so there are no charges involved here. And these webinars are a really great platform for anyone who is looking to get into this industry vertical by learning the technologies that they are interested in. So to be a part of this entire webinar, so we can here refer to this link here. Let me share this link with you all so you can click on join this group, and then you can not be notified for the entire schedule that has been planned for the entire month. Let me share this link with you all. Here you go. And to be a part of the webinars directly, we can refer to this link here called Edurka Masterclass, so we can directly have the access to all the webinars that we can register for directly in a given month. We can also do that. All right, so I've shared this link with you all as well. Here you go. Now here, to be a part, okay, so first of all, let's get started on the topic that we have to discuss. So first of all, we are going to discuss on the introduction to Python. Then we are going to talk about Python features, the introduction to data analysis, Python packages, what exactly we mean by NumPy, and what are different libraries available, like we have pandas and matplotlib operations. And then we are going to see a small hands-on on these different libraries. So Python, as we know, is one of the most dynamic languages available out there. So Python is used for different requirements. So again, it is used for web development as well. It is used for data for web scraping. It is one of the main drivers in machine learning and data science domain. And there are multiple advantages of working with Python as well. First of all, Python is an open source language. That means Python, we can say, first of all, Python is a high level language, right? It's a high level, it's object oriented. And again, it is easy to learn because it has a least amount of grammar as compared to other languages. And there are multiple features available for Python. So if we talk about features, then Python is, again, offers simplicity. So Python offers simplicity. That means, again, there's less syntax that we have to learn, especially for those who are coming from non-IT backgrounds. It is open source. That means there's no licensing involved here. It is free for everyone to use and alter as needed. And then it is portable as well. So Python can be shared and it can work in the same way it was intended to, seamless and hassle-free. And then it can be embedded as well. That means Python can have snippets of other languages inside it, like we have C, C++, Java. We can easily embed them within Python. And then it gets well interpreted. That means, again, we don't have to worry about the large memory tasks and other heavy, against the CPU heavy tasks, as they are taken care by Python itself. And then it has a collection of huge number of libraries as compared to other packages. And then here we have OOPS. So OOPS means the object orientation simply helps to break down complex problems of this world into code. And again, we can provide security to obtain better solutions as well. Now, who exactly uses Python? Now, Python is used by multiple domains and almost every company out there, they have been using Python, like Google, Dropbox, NSA, NASA, Netflix. Almost every company, every solution that we can think of has some way or the other Python embedded in it. And now if you talk about data analysis, then what exactly data analysis is? So it's simply working on analyzing large sets of data and trying to make some meaning, or we can say derive some meaningful insight out of it, right? So again, data of unemployed youth across the globe from 2002 to 2020. So the percentage increase in unemployed youth in Afghanistan between 2010 and 2020. So we want to analyze this kind of situation. So there we have to make use of Python for that, because we have extensive libraries available in Python to help us out. So starting with Pandas. So Pandas is basically a library written for Python programming language for data manipulation and analysis. So Pandas is again useful for heterogeneously typed columns, and again where we can work with ordered and unordered data set as well. So we can use it for creating multiple data frames where we can store data, and then we can even perform calculations on top of it as well. And then we can also, by using Pandas, we can slice the data frames, we can change the index, we can convert data, we can join and perform join and merge operations. We can concatenate multiple smaller data frames into a single data frame, and we can change the column headers as well. We can always do that. And then if you talk about the slicing component here, so we can simply slice the components into two different parts by using Pandas library. So for example, now for seeing a small use case, what we can do, we can create a small data frame. So for that, we can make use of Sublime Text. Let's do one thing. Let's create a small CSV file directly. Let's save it as, suppose, data.csv. And here we can define, multiple data sets that you want to make use of. For example, let's say in this CSV file, we want to define what we have, we have index, initial, okay, have index, integer rate, and interest rate, and then we have GDP thousands, right? So we have index, then we have the index, then we have the interest rate, and then we have GDP. Suppose we have GDP. So here we can create any small value in terms of CSV. For example, we have 4 values, right? We can define, suppose 2001, interest is at 2, GDP as suppose, let's say, GDP has been defined in 1000 itself. So we can define any value for GDP here. Suppose here we define 50, 2002, suppose as 2. Here we can have about 45, 2002, or suppose 2003. Here we can have 2. Here we can have suppose 54. And then we can have 2004, and interest rate suppose as 3, and GDP suppose as 52, or suppose 55 itself. So here we can have what? A simple CSV format as a comma separated value. That is what we define in terms of CSV, correct? And now we want to work on defining. Again, here we can go ahead and create any kind of slicing options as well. So basically, slicing means what? Slicing, it means if we want to carve out the entire data set into smaller components, right? If you want to carve out you can say large data set into smaller components, then we can do that easily by using the slicing component as well, right? So for example, now we can make use of the same slicing as this one, or we can again use different values as well. For example, let's take another value, or we can make use of something called as data frame. Just let's do that. Just a moment. Just a moment. So even I can share this with you all for your reference. Just a moment. All right, so we can make use of any Jupyter notebook as well. So in case we have any kind of Python notebook available, we can make use of Colab, or we can make use of Jupyter notebooks as well. We can do that. So here we can, now if we have Jupyter Notebook installed locally, then we can make use of it. In case we don't have the access to any Jupyter installation, then we can use another notebooks like we have Colab. We can do that. So here we have the access to a Jupyter notebook. So we can go ahead and create a new notebook as well for Python 3, or we can use any of the other IDEs available, like we have PyCharm. In case we have access to PyCharm, we can use PyCharm. In case we have access to this kind of Jupyter notebook, we can make use of it. We can define any, we can make use of any platform. All right, we can do that. Whichever we are comfortable with. For example, suppose here we want to work with PyCharm, we can even work with PyCharm as well. For example, let's say here we want to, first of all, import pandas. So we can define pandas as PD, right? Pandas is a library available, so we can import pandas as PD. If we are using PyCharm, then we have to ensure that we do have the pandas library installed. And if we don't have it installed, then we can navigate to the section called as up here. Now, here we have settings. Under settings, we have project interpreter, right? So here we have to go to the project interpreter, and then within this we have to choose. We have to choose the library. We can say the interpreter that we have, and then we can define the packages. So here we can see which all packages are currently installed in this current interpreter that we are currently using. We can see the entire list. In case you want to install more packages, we can go ahead and click on plus, and we would be able to install any packages directly from this entire link. We can do that. So sometimes it does take a while for this entire list to be populated. But again, in case we have that, then we can make use of all the packages available. As you can see here, we have pip for this one. But again, currently we're using 3.8 at base Anaconda. And here we have almost every packages that we need for data science already available. So let's say here we can define import pandas as PD. We can define any data frame, for example, XYZ. Here we want to create a data for web. We can define for web. And here we can define, let's say, we want to, first of all, define details for day. Within day, we can define, let's say here we can define a simple array of numbers, for example, 1, 2, 3, 4, 5, 6. All right. And then we can go ahead and define the another variable for, let's say, for visitors. So here we can find, suppose, for visitors. And for visitors, we can again define the value for them in terms of the array. For example, on day 1, there has been, suppose, 100 visits, or suppose 1,000. On day two, it has, suppose, 1,200. On day 3, it has been 750. On day 5, it has been, suppose, 1,500. On day 5, it has been, suppose, 950, and so on. Again, and one more, as suppose we had 1150. So these are the number of visitors that we have received on the website. So we can define that. All right. And then we can go ahead and now here we can go ahead and create the entire data, or we can define the entire data frame as well, right? So here we can now, if you want, we can also define the bounce rate as well. So let's do one thing. Let's add one more value as bounce rate. We can define this one as bounce rate. And here we can define under bounce rate, we can define any value. For example, suppose on the first day, bounce rate was 60%. Then we had, suppose, 50%. Then we had 20%. Then we have, again, suppose 30%. And then on day 5, we have 50. Again, on day 6, we have 20. So for 6 values, for 6 days, we have 6 number of visitors, and then we have 6 bounce rate also defined here. All right. And then once we are done, we can simply define our complete data frame. So here we can define this one as DF, as data frame, and we can make use of pandas. And then we can define, suppose, as data frame for what we want to define, suppose, for XYZ for simple web, we can say web data frame, where we have saved all of these values as a simple CC value. So we can also define, this one as, we can directly import the CSV file, or we can go ahead and define our own data frame like we defined right now. We can define it. No, it's not. We have changed that. Let's see, we have changed that. All right. As you can see here. So we have simply missed it out. So now we have changed that. Thank you for pointing it out. And then if you want to print this, we can simply use print as DF. So now currently the entire data frame is going to be printed. Right. So here we can, now if you want to run this up, we can simply click on run. And the entire data frame is going to be printed again. As you can see here, the entire data frame has been printed on day 1, how many visitors and what is the bounce rate that we have received. All right. Now here we are. Now if you want to go ahead and slice it, so then here we can customize this one. For example, we can also, now for slicing the element for only 2, right? So only for the first 2 details. So we can define. So here what we're doing here simply slicing the first two rows. So for that, we can define print, and here we can define df. Now, from the given data frame, we want to print head, and from head, we want to print 2. That means this first two rows should be printed here. We can define df head 2. So now if we run this up again, we would be able to see the data frame along with the slice element, as in the first two elements have been printed, as you can see here. Now, just to avoid confusion, let's do one thing. Let's add this one as a comment. So now if we are printing the first two head, that means we can see here only the first two entries have been printed. If you want to print the last two, then we only have to define this one by tail. And if we define tail, then the last two details, I think the last two entries are going to be returned as a response, as a part of slicing the elements. All right. So first of all, are we clear on how we can slice the elements? Please give me a quick information, everyone. Are we all clear on how we can slice the elements? Great. Thank you for the information, everyone. Great. How can you slice middle elements? Now, here we can define the index value here. If you wanted to define that, we can simply define the index value. And again, that's how it is going to be simply printed. And if we want to slice out from a given range, then we can define the range as well. For example, here, we can define df, and then within df, we can define from 2 to 4. So for example, here we can define how exactly we want to, like what are the values we want to return as a response. So we can define, suppose we want to return the values, suppose from 2 to 4. We can define the index value, as you can see, from that means from second column 2 till 4. That means these two have been returned as a response. Clear now? Mansi? Great. Thank you for confirmation. Just like we do for any arrays here, we can do the same thing here for these elements as well. All right. And if you want, we can go ahead and concatenate multiple values depending upon the requirement. We can simply go ahead and join the values as well. Now we can take another example, or we can stick to the same example if you want. For example, let's do one thing. Let's say we create another data frame. We can copy this one. We can copy this one. Suppose now here we have two data frames. We can name this one, suppose, for ABC Web, and here we have the same days. Here we may have different visitors. Suppose as 2000, we may have suppose 1800. We may have suppose 750. We may have suppose again 1000 itself. Then we may have 1950, and we may have suppose 2150. And the bounce rate we have, suppose this maybe 30%. This may have been 20. This may have been 20 again. This may have 30 again, 50 and 20. So what we have here, we had two data frames, XYZ Web and we have ABC Web. We can create two data frames as well. By copying this, we can define this one as df1, this one as df2, and this df2 will be for ABC, not for XYZ. And now if we want to go ahead and print one specific, we want to even concatenate both of them together. So we can add a simple function as concatenate, and using concat, now here we can define concatenate as a simple data frame. And then we can define by using pd.concatenate, we can define what exactly we want to concatenate. We want to join which two data frames. We want to join df1 and we want to join df2 as well. All right. So we can define this one as a part of concatenate function. And now if we want to print this, we can simply define this one as a simple print statement where we want to print concatenate data frame. So these two data frames are going to be joined together and they are going to be printed. We can do any operation we want to there. So as you can see here, both of them have been joined together. So now we have days, right? And then we have the visitors and the bounce rate being defined for both. All right. So are we clear on how we can concatenate them together? Please give me a quick information, everyone. Great, thank you for confirmation. So can we compare? Yes, we can compare, we can merge as well, we can do anything. For example, say here we want to merge this, right? So if we are looking to merge this, then we simply have to replace concatenate by using merge. That's it. Suppose here we can, or let's do one thing, we can copy this. So here we can define this one. Suppose here we can name it as suppose merged, and we can replace this with merge as well. And then we can define which data frames we are going to merge. So in here, we don't have to be specific. We don't have to include these two different brackets. So we can simply define merge. And now if we want to print merge, not the concatenated one, then we can simply define merge. So again, these two data frames are going to merge together, and that's how they are going to be simply printed as a part of index value. But again, here we have to ensure that we have to, again, which column we want to make common, right? That is what has to be defined here. All right. So as you can see here, this has not been printed because there is no index value we define here. We have to define a common value when we are going to merge it, right? So for defining a common value here, we have to define index, and then under index, we have to define which should be the common value defined here. Right. So again, here we can define days. We can define days as a common index value. For example, here we may have multiple details. Suppose we may have index value defined as years, right? Or suppose we may have index value defined as number of days as well, right? So we can define this value as which is going to be our index, and that's how that index value we will use as a base, and that's how it is going to be joined together itself. All right. So for example, here we can define suppose as 1, 2, 3, 4, 5, and again, suppose this is something that we can define for both. Let's say we add the index for both.
You need to unlock your iPhone first.
Webinar, sir, before merging the elements, so now just like we need to have a common element, right? We need to have a common element defined. Then only we can think of merging them together, correct? That is what we have to do here as well. We have to find the common index value that is going to be used for merging the elements together, and that's how we can merge them. All right, as a part of common index value. Clear now? Great. Thank you for confirmation. And if you want, we can take up another example as well. So again, if we find this one up to be a bit confused, we can take up another example as a reference. So basically here we can define pandas. Let's suppose here we have two different data frames available with us that we want to make use of. Like we already have one previous example that we can use for a better understanding. So here we also have two different database. We have also had two different data frames defined, and now what we have done, we have simply merged them together for finding out the entire merge details. Now this is another program that we already have, and again, if you want, we can simply run the file here. So having the common index value, they are both are going to be merged together, as you can see here, based on the common values. So now we have, although we have two data frames, but again, they both have been merged together itself. That's how it works. And same way, we can perform multiple operations, not just slicing here. We can define merging. We can simply go in and work on joining the elements. We can work on concatenation that we discussed. So there are multiple libraries that we can define as and when required, as per the requirement. So are we all clear to this part? Please give me a quick information, everyone. Yes, webinar merge simply takes the common records, and that's why we define the index record as well. We have to define the index record. That's how it works. Without having a common index number, it is not going to work at all. Great. Thank you for confirming, everyone. So as it's been time now, so let's say we wrap it up for today. And first of all, thank you so much for being a part of this entire session. And if you really enjoyed today's session, then please do rate us excellent in the feedback form as a small token of appreciation for the hard work and time that we have put in. And let's meet at the same time. Let's hope to see you all soon. Join the entire session so that we can continue our journey that we have started today. So again, thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.